I'm going to show you the process of going from CAD files to the first design for an injection mold and first parts. Welcome to another episode. So this is going to be very different from other episodes. I have no idea if it's going to be of interest to people or not, but I'm going to throw it out there anyway. Let me know what you think. What I'm going to focus on this time is taking a throttle project, which is this guy right here. This is a 3D printed case, and we just got back the first T1 samples of the injection molded case. You can see it's still shiny because we haven't put the texture on. So what I want to do is give you an idea of where we started, which is back in April, I think, with preliminary feedback from the injection molders, and then move from there to where we are today. You can see that in April we got a really detailed file from the mold makers that had a lot of information about how they were planning to make the mold. So here you can see they've shown us where the parting line is going to be. They obviously haven't shown us all of it because the parting line is only shown for a few of the buttons, but at least it gives a fairly good idea of where the parting line is going to be in all the different places. Here's another example of the parting line. Now, one of the things I could have done when I got this is to modify the draft based on the parting line so that it matched where they were planning to put the parting line, but it's probably easier to let them do that than for me to do that. They also gave us information on where they thought the gate would be. So this is the location where the plastic will be injected into the parts, and you can see that in all cases, the plastic is injected into one location, and then it flows around away from that to the rest of the mold. This right here is called a subgate. This is kind of interesting because you have the runner here, which brings plastic to the mold, that goes down to a gate here that goes up into the part. The reason they do that is because that way they can inject the plastic here on the inside of the part where it won't be visible to you as the user. Here it doesn't matter because these tabs are not visible. In this particular case it is visible, but it really doesn't show up that much on the finished part. They also did draft angle analysis. They found a few places where I didn't have the draft angle correct, so they needed to modify it. Some more draft angle things. Here they said we have a radius that we need to remove, and that's fine. There's also an undercut because I didn't have any draft on this part of it, so they needed to fix that. And they gave us two options for how to deal with it. This is option 1, then here is option 2. So I believe we chose option 2. Next, some more draft angle analysis, and here you can see they found some undercuts that will need to be removed. And they also found some sections that were too thin. Now this particular one here, we said it's okay. We'll really need this to be fairly thin because this is where the thumb wheel goes. If we made this any thinner, it could rub against the thumb wheel, so we didn't want that to happen. The plan here is that they'll make a few changes, hopefully, and then when we put texture on the parts, then you shouldn't be able to see that. At least that's the plan. This is an analysis of sink marks, so you can see that where we have the screw holes here, there's potential for sink. Again, more sink mark analysis. No issues up here on the battery door. On the thumb wheel, there are some issues around these sections, but they're not going to be visible, so it doesn't matter at all. Ejector pins are how the parts are removed from the mold. They're basically saying the ejector pins are going to go on these surfaces, and they're not saying exactly where they're going to be. And then they suggest adding a slot here, and this is, you can see, in order to avoid mismatches between the two parts, because when you make parts like this, there are some tolerances when you make the mold. It's not going to be exactly the way that it was in CAD. It's going to be fairly close, but usually they get within 1 or 2 thousandths of an inch. So having a gap around here can compensate for that. Another thing is that you can have shrinkage variations between the different parts that can cause some issues as well. So having a gap helps mask those areas. And then we need to provide information about what surface finish we want for the different parts. You can go all the way from glossy to a fairly rough exterior, and we're going to do something that's in between. So it's definitely not going to be glossy, and it's not going to be really rough either. So it's going to be something in between. The next step after that was to make some changes to the design itself. There were some things I didn't like. The battery door, for example, didn't work as well as people liked. It was a little harder to open. People felt that it required fingernails, that sort of thing. So I spent time redesigning the battery door, went through a number of iterations, and then we finally started the process of actually moving toward injection molds with the final CAD design in July. So what I'm going to show you next is a new set of revisions that we got in July. Back in July, we got a file from the mold makers with suggestions for changes to make to the parts so that we would get better results in the molds. And most of the suggestions are fairly straightforward. Things such as changing the draft angle or eliminating some of the radiuses that I put in there. Here's another one, which is to increase the depth of the hole to reduce the sink marks. One that's more interesting, though, is this one here. I used a spline to create the cross-section for this. And I used lofting. One of the things that apparently happened as a result of the lofting is I have a section here where there's an undercut, or at least not enough of a draft. And this appears both on the outside as well as on the inside, as you can see here. So they suggested modifying the shape to fix that and make sure that there is a draft on both sides. Again, other things such as modifying the draft angles, etc. When I put in the draft angles, either I didn't get them correct, or I didn't add them, or they needed them to be different. One of the things about designing something like this up front is it's really hard to know until you make the mold exactly where the parting line should be, and therefore which way the draft angle should be. The final change they made is to make the alignment of the mold halves less critical, so that it looks like they fit together better even if there are slight variations along the way. Here's the injection mold itself, and one of the things that's interesting about this is just how many parts there are. You can see I've grouped them by different categories, and so we have 250 close to 300 parts, or over 300 parts. What I'm going to do is hide parts of this, but first I'll give you an idea of how this works. Down here is the ejector pin mechanism. So we have a number of ejector pins like these guys here, I believe. No, actually not that. Maybe this guy, I'm not sure which, that are connected all the way from down here up into the part. And there's some mechanism, I'm not sure what it is, possibly pushing through here, that pushes up on these plates and causes the part to be ejected. So let me hide a bunch of stuff here and get down to kind of the basics. This is showing the core side, and then we have the 4 parts that are going to be made from it. So I can hide those 4 parts. And now you can see what the half of the mold looks like itself, and you can see it's quite complicated with all of the sections in here. There's also this concept of core pins, and so the core pins are where they have extra pieces, like this guy right here, and I'll show you what the shape looks like for that. If I can find it in here. So I'll click on it. Okay. So I'm going to show you just that shape. So that's a piece that goes into the mold and forms the section here, which is for the lanyard. Then we have other pieces here which provide holes for the other side of the case. Now I'm going to show you the ejector pins that I mentioned before, and these are the pieces that go down into the ejector plate, and this is what is used to push the parts out of the mold, because with the way that it sits on right here, the part is going to tend to shrink inward, basically going this way here and this way here. And therefore it's going to have a tendency to stick to this side of the mold, and same over here. So these pins, all of these different colors, are going to push the part away from the mold and release it from the mold. Now let me show you the other side. So I'm going to get rid of the ejector pins, and I'll show the cavity instead of the core and flip that over. And you can see that this is a much simpler part, and the parts have a tendency of coming out of that side of the mold a lot easier. Here are the 3D printed version on the left, and here's the injection molded version. And you can see that there are actually a few slight differences, like in the battery door here. So this is the design before I revised the battery door. Let me take these apart and show you some of the details on the inside of the injection molded part. But before I do that, there are a couple details I'm going to try to show. One is, if you notice here, the two halves don't line up very well. It's probably a little bit hard to see, but it's about 20 thousandths of an inch further that way for this part than for this part. I'm not sure what caused that. I think it might be shrinkage, because the same thing happens here on the sides. Again, it's probably a little bit hard to see, but I can certainly feel it that way. Now, one thing you'll notice when I pull this apart and turn this over is that not all the screws come out, and that shows you it's actually fairly tight tolerances for the screws, which is what we want, because that means that the screws are providing the alignment between the top and the bottom halves. Let me take out the other parts. Oh yeah, so another thing is, if you look right now, you can see that this thumb wheel is very loose. The reason it's very loose is because we used what's known as a steel-safe design. So in a steel-safe design, the mold can be modified to give a better fit by removing steel. Let me get the focus correct. So this hole here, the D-shape is D-shaped hole. Let me see if I can get closer. So this D-shaped hole is larger than it needs to be, and that way they can slowly remove steel from the mold until it's a very slight slip fit over the shaft of the encoder. Let's take a look at some of the details in here. You can see there are some marks right there and there. That's where the ejector pins push out. And if we look carefully, see if I can find it, we can find here it is. So this right here, I'll try to get a better picture of that. So this right here is where the plastic is injected. That's where we have the submarine gate. And then the rest is pretty straightforward. Again, we have some ejector pins there, which is what pushes it out of the mold. Same thing for the top half. We have ejector pins in various locations, which is what produces those marks. That's what pushes this out of the mold. And then looking here, you can see that this right here, the plastic is a little bit white. And the reason it's a little bit white is because they're sheared off the gate right there. That's where the plastic came in, and it filled this entire part from that one location, which I think is pretty impressive. If we look at the battery door, this is the location of the gate right here. Again, you can see that the plastic is a little bit white. And then if we look at the thumb wheel, let's see, where is it? There it is. So right there, see if I can focus this better. So right there is the place where the plastic is injected into the thumb wheel. So I think that's pretty amazing how that's all done. We've been taking a look at the samples that we got in a lot more detail, and actually on the screen here I have a document that I'm putting together that lists all of the things that we want to change. We're still working on that. It's been about a week since we got the T1 samples, and there's some going back and forth between us, between me and TCS and various other people on the team to figure out the things that we need to change. So in the next video, I'm going to dive a little bit deeper into the things that we ended up changing after we've had some discussions with the mold makers, and then give you an idea of what the next steps are going to be after that. I believe we're going to get T2 samples. I believe that's what they're going to be called. And we'll take a look at those, and with any luck, our T2 samples will be good enough that we can go directly to making the parts and do a small production run. If it's still not good enough, we'll have to do yet another iteration. And so what you can see from this is that it takes time to do these things. I don't know how long it's going to take for the next iteration, but I'm guessing probably about 2, maybe 3 weeks. We'll find out once we send this file of changes to the mold maker and get the reply. I hope you enjoyed this episode. I know it's been a little bit different. Please subscribe, give me a thumbs up, and comment below. See you next time.